Hello! Today, uh, we are back in it again with another epic video. Uh, from our last few lessons on complex numbers and integrals, I think it is ready for us to move on and try a problem that involves both at once, right? Complex numbers and integration. Should be a fun exercise. Let's do it. And so particularly, the we're gonna try to figure out what this integral could be. What is this integral right here? That is the integral from 0 to pi over 2 of cosine to the 2k theta d theta, where 2k is a even power. Okay, and you might be thinking, how are you supposed to do this? Right? Well, I mean, yeah, it's tough, right? Right. Uh, okay. Let's think. Okay, let's do some groundwork on this side. So let's brainstorm. How can we figure out this? Well, let's try something like an integral cosine to the cosine squared b theta. That's not bad. That we can use the double angle identity. That's the 1 plus cosine 2 over 2. And that works out pretty nicely. And then perhaps we can try cosine to the power 4 theta. Once again, we can do cosine squared, and then that's squared again. So this is equal to cosine squared, and then we're gonna square it. And what you would do is you would substitute in the formula for the power reducing formula for cosine squared into this formula, and you can work out the integral from there. But this is rather messy, isn't it? Every time you have a power of cosine, you need to convert it into some other form that involves just a factor. That involves just a factor of theta. So hopefully, by using complex numbers, we can arrive at a formula that will allow us to compute this integral. And we're going to do this in a number of steps. Right, we have from A to E. Right, and then that's our goal. This is our goal. We hope to achieve this. So let's get right into it. And okay, let's go with part A. Let's start with part A. Okay, let's see. Let's see, how can we do this? Okay, part A. Show that z to the n plus z to the minus n equals 2 cosine n theta. Okay, we're starting easy. Well, we see a general power, so we should probably use Demois' theorem. So I don't even know how to spell it. Demois. Okay, Demois' theorem. If you guys don't know about it, I'll just quote it here. So you can. So essentially, if you have a complex number, z to the raised to the n, well, that's just going to be cosine theta plus I sine. Oh wait. Okay, z in this case is just that. So it's just this expression. And that turns out to be, according to De Moivre's theorem, this turns out to be cosine n theta plus I sine. Okay, not so bad. Let's just apply the formula. So we know that z to the n is equal to this, so let's just calculate what z to the minus n. Well, that's just going to be cosine n times minus n theta plus I sine n times minus theta. Well, cosine of a negative angle is just, it's original because it's an even function. And then sine is an odd function. This sine is a odd, and then that's even. So this is equal to negative I sine. So you can just add them up. So therefore your z to the n equals 2 cos. That's part A. Okay, now let's do part B. Well, we have to use the result from part A, right? So let's just use the formula, I guess. Well, what exactly is cosine theta? Well, we can just let n equal 1 here. Let the n here equal 1, and then that gives us cosine. Almost cosine. But we'll get there. So we have z plus z to the minus 1 to the power 4 is equal to plus 4 power 3 z to the minus 1 plus 6 square z to the minus 2 z to the minus 3 plus z to the minus 4. Okay. Well, this is just cosine theta. So let's put on different colors. This is cosine. This is 2 cosine theta to the 12th power is equal to. Let's rearrange this. This is plus well, that's a constant, so it's 4 outside z minus 2 plus 6. Okay, well, what is this? What is this? This is z to the minus. This is just that formula, and this is also this formula. So let's just substitute it in. So we have this is cosine. This is 2 cosine 4 theta. 2 cosine 2 theta. Well, that's easy enough. This is we can divide both sides by 16. So therefore, your cosine to the 4 theta. Okay, let's rewrite that. Cosine to the power 4 theta is equal to 2 over, that's 1 over 8. Cosine 4 theta. Plus, that's 8. That's going to be 1/2. 2 there plus 6 over 16, which is what? I guess we can just spread it as 2 through, right? So this is, nice.